Yeah, thank you. Well, thank you all for coming out tonight, this evening. I can tell from talking with some of you that you're very excited about the opportunities for exploration that the reforms, the energy reforms in Mexico are opening up. And so, just imagine how excited I am. And why? Because this opportunity brings together all the learnings that I have had over the last 47 years since I arrived in Mexico as a young geologist, as John had mentioned. So it's these learnings, some of these learnings, that I would like to share with you tonight. Next one. This is the cumulative discovery history since the turn of last century, right up to the present. And it has a typical S shape of a mature country or a mature province. In recent years, there hasn't been very much, haven't been any major discoveries being made. Oh, well, you say they haven't been investing. Next one. Well, this is exploration investment over the last 60 years. And yes, okay, I can understand why around this period of increased discoveries, we've got increased investment. That generally makes sense. But look at the last 10 years in here. Increased investments have hardly made an impact at all in the discoveries. You could say, oh well, you know, they didn't have anything left in their portfolio to explore for. But no, this shows Pemex's portfolio of leads, 1,700 leads scattered over deep water, the shelf, and in some onshore basins. So they've had plenty of opportunities, and I'm sure, well, I don't know for certain, but I'm sure that they would have drilled the best ones first. Their high-ranked leads would be the ones that they would have wanted to explore for first. So, what do you do? Well, I know what some of you would do. You would follow your experiences from US trends into Mexico. Well, yes, but the Eagle Ford liquids trend only goes about 100 kilometers before it gets uplifted and eroded. The South Texas gas basin, the Rio Grande Bayman, quickly turns around and doesn't go for very far. And the Perdido oil, the Perdido Fault Belt, only goes about 200 kilometers further south. So what are you going to do for the rest of the country? What are you going to do? What can you bring to explore for the rest of the country? Because the rest of the Gulf of Mexico, the southern part of the Gulf of Mexico, is quite different from the northern part. So what I think a lot of you would do, basically it's a completely new country, I think what a lot of you would do, next one, is you would go back to first principles. Look at plate tectonics, consider global sea level changes, anoxic events, sequence stratigraphy, depositional environment, and how these impact the petroleum systems. And that's what I'm going to go through with you this evening. What I'm going to go through with you is go through the plate tectonics and these different aspects and look at the petroleum systems elements. Now, just so we're all clear, what do I mean by that? I mean the source rock and the charge that might bring, the reservoirs, and the traps. Sometimes they're stratigraphic traps, sometimes they're structural traps. So I'm going to take you through the paleogeographic evolution of the Gulf of Mexico, concentrating on the southern part of the Gulf, and comparing what's going on there with what you're more familiar with in the northern part of the Gulf. Next. Now, I think, I believe that a few months ago you had a very good presentation on the crustal structure of the Gulf of Mexico. And there has been quite a lot of research, a lot of detail. But I like to think of a very simple model, it's too simple for the experts, but it works for me, of Yucatan just migrating south along two transform margins. And this is the transform margin in the eastern coast of Mexico, and we'll see the effects of that during the Jurassic. And the northern part of the graben, the big graben that develops into the spreading Gulf of Mexico, the northern part I'm calling a subsiding passive margin, and the Yucatan part a high-standing passive margin. So next one. So let's look at a cross-section through that to see kind of what I mean. So this is a very simple diagram showing the extended continental crust underneath most of the US, oceanic crust in the central part of the Gulf of Mexico, and then coming on to the high-standing Yucatan platform with very little extended crust underneath it. And you can see the much more subsidence, much more sediment, pile of sediment here on the US side than on the Yucatan side. And that has a lot of implications for thermal history, thermal maturity of the source rocks, for the kind of sediments and sediment source. So please bear in mind that what you're familiar with in this area could be quite different on the high-standing side of the margin. Next. So let's go through the history of the Gulf of Mexico. You're all familiar with the extension, the rifting, the Trenton series in the Triassic and Liassic, and the Proto-Atlantic opening up as one of those rifts. But you might not have been aware that, in fact, coming in from the Pacific side, from Tethys, the sea invaded the rift in eastern Mexico. And that's supported by ammonites that have been found here and up here. Those sediments are actually lignitic, organic-rich source rocks. And Pemex has drilled wells in this area and found gas. They just haven't been able to establish production yet. So this is an interesting opportunity. And just imagine, who's to say that the sea didn't invade up into here at some point in time. Next one. We move on now to the Calovian, and as you're all familiar with the big depot center for the Rouen salt, the sag phase of the development of the Gulf of Mexico. But there again, there's a re-entrant coming in from the Pacific into the Tampico Basin area, and these are also source rocks. Next one. Here I've tried to capture that very interesting time, right as the sea was, the eustatic rise in sea level was flooding the sag phase of the opening of the Gulf of Mexico, such that we have, and I've lumped together here, the Norphlet Aeolian sands, which rim north, that you're very familiar with, and the new discoveries here, for example, and rim also are present down in the south. And of course, at this time, southern Mexico here is not that far from the Florida Panhandle, for example. There is an oil field here called Explorationists that Pemex has, and it is it produces from these sands, just like the Norfolk, and it produces algal sourced oil, which presumably, which they think has come from the microbial carbonates, very similar to the MLZ, the basin and Smacko. So the southern part of Mexico here could have systems similar to the north, but only one field has been discovered so far. However, here on the west, coming in from the west, they again have a marine incursion, marine source, and it's a source rock. So the next one. By the time we get to the Cambrian, of course, the global sea level is rising, and we get oolites, and I've kind of lumped here the Smacko oolites and the Cambrian oolites of the northern Gulf. But you also get oolite production in southern Mexico and around blocks, island blocks here, that are jostling up and down as a result of the transform as the Gulf of Mexico starts to open up. So this is the incipient opening, the first drift phase in the Gulf of Mexico. Again, major source rock system around these islands, charging them. And I don't have a diagram of the latest phase of the Jurassic, the Teutonian, but as you all know, this was the major eustatic sea level high, and what it did is it basically flooded much further in here and flooded most of these islands and led to a major anoxic event which caused a major source rock to be developed. This is the source rock that you know is the Haynesville up here, and down here it's a major source rock, and also the major target, really, of the unconventional oil to be found in eastern Mexico. Now, a lot of things have been happening in the Jurassic, so let's just very quickly go over what they were. We've talked about the Liassic, and the difference with the US is that there were marine shales coming in the eastern side of Mexico, which are source rocks. Next one. We talked about the Colovian salt, which is in Mexico is actually, as I'll show later, is absent over large areas. But we also talked about marine shales coming in and their potential source rocks. A lot was going on in the north, in the Oxfordian, with the Northlet sands, which are only a minor reservoir in the southeast. An opportunity to be found, perhaps more to be found there. We talked about the MLZ type source rock, again, only a small part in the southeast. We talked about the oolites and the marine shales. Next one. We talked about the Cambrian, which are good, the oolites are good reservoirs and main source rock for oil in the there, and in the Teutonian. I just mentioned that this is the main source rock for the oil all over Mexico, and also the main target for unconventional oil and gas. Now, when we move now into the Cretaceous, things started to settle down. And I jumped here to the Albion, but just let me say a little bit about the very earliest part of the Cretaceous. The sea level actually fell, actually dropped, and as you know, the Cotton Valley deltas prograded from the continent over into this area. Well, you don't get that happening in Mexico. You don't get plastic developments around here because there was no major continental landmass. So now moving up to the Albion, root, as you know, Brutus Reefs, the Edwards Reef, developed around on the northern rim. But in the south, these islands, these basement highs developed as atolls. And because of the different changes in sea level during the Albion, these atolls were constantly exposed and then graded up and then exposed and graded. And that led to two major things. One was that the karstic porosity, caverns and karstic type of porosity was developed around these highs, but also carbonate breccias were shed from the highs, and these breccias are some of the major producers in eastern Mexico, specifically in Puerto Rico field here, but also in the south. Next one. Now, in the Upper Cretaceous, and now here I've lumped quite a few things together. In the Upper Cretaceous, we get, of course, in the low stands, we get the Woodbine Tuscaloosa sands prograding way over the shelf and out into deep water. And a little bit later on, coming off shedding off the proto-laramide, if you like, we get in the U.S. we get Navarro-Taylor, and in Mexico we get some sands as well that don't actually reach the Gulf of Mexico. But in contrast to what was happening in the north, in the south, there were no plastics coming in at all at this time. And we have the carbonates continuing to build up the shelf, building up the shelf up into the Upper Cretaceous. And because of all the sea level changes, breccias continued to be shed off the shelf margin. And these produce very thick, very porous reservoirs. Next one. So, just briefly to go over what was happening in the Cretaceous, we had Cotton Valley sands are present in the US, but don't expect to find them in Mexico. The Sligo shelf margin, yes, but not very productive, only in the north. We had the Edwards shelf margin, which is a major reservoir in Mexico due to karstic caverns and reservoir enhancement. And what you don't see around the Edwards in the north are breccias being shed off the platform margin or major reservoirs. In the next one, in the Turonian, we get Eagle Ford shales coming across. In both cases, we don't get any plastics from the Woodbine Tuscaloosa. Chalks, yes, we get a chalk, but it's more argillaceous, and it's only a reservoir when it's highly fractured. But we get shelf margin carbonates, and then breccias being shed off them, and we get some sands coming in the north. Now, at this point, I can't resist not showing you a photograph of a rock. This is a sample of the breccias being shed off the carbonate shelf edges in southern Mexico. It is the major reservoir in southern Mexico. It is the mother lode, as you might say. And it has triple porosity. It has intercrystalline porosity. You can see it here impregnated with oil. It has buggy porosity and intensely fractured. And this produces an initial production, like in the main Cantarell field, in the order of 30,000 barrels of oil a day. Major production. So let's go now then to the Cenozoic and talk a little bit about tract formation. By this time, of course, we get the laramide orogeny reaching over into eastern Mexico, which you do not see the effects of in the US Gulf Coast at all. They produce some gas in this area. The folds produce some gas in this area. gas shows in this area, gas and oil down here in the Veracruz Basin. So these folds are not very, very productive. The big folding event is a later Miocene event called Chapaneca here in southern Mexico that causes thrusts and folds in the onshore and offshore southern Mexico. And it's here that you get a major duplex forming the Cantarell, the giant Cantarell, which you just don't see the effects of that at all in the northern Gulf. This shows the present distribution of salt because the area in between is occupied by oceanic crust, so the salt split and move apart. But what that means is that all the tectonic relationships that you're used to seeing here in the northern Gulf, from pillows and walls and piercements and canopies and wells, all those trap-forming elements you can only expect to see in the northern part here and in the southern part. But there's a vast area of Mexico where you will not expect to see those. That's a big, big difference. And then we have a late extension compression phase. Here, of course, is the extension due to the main plastic deposition of the Mississippi, with the folds developed in front of that. A similar situation developing in the Rio Grande embayment, with the Perdido folds developed out in front. And these are productive, of course. However, here you get a major extension with major long elongate folds called Mexican ridges, which have not had production established on them yet. They're not yet productive. And here in Catemaco, you get folds developed here due to extension, grabens extending here that are causing folds there, and there's been some gas that's been found on these folds. So here again, a difference between these folds and these, because these in the southern Mexico are shale-based. They're not riding on salt, they're riding on the lower tertiary shale. So just to recap then, we have Laramide, not in the Gulf of Mexico. I'm sorry, not in the US part of the Gulf of Mexico, but yes, in Mexico, and causing some traps. But the main trap-forming system is in the southeast part of Mexico due to this Miocene tectonic event, which you don't see at all in the northern Gulf. Okay? Salt, yes, forming traps and seals in both sides, but as I've shown, absent over large areas. And extension, the growth faults, yes, on both sides, and gravity folds, also forming major traps. Before we can kind of conclude, though, I want to say something about the clastic reservoir quality. Here, as you're very well aware, Mississippi sands are good quality sands coming all the way down off into deep water, ultra deep water. But as you go around into Mexico, the sands coming off the Paleo Rio Grande are a mixture of quartz, feldspar, and lithics, and so the quality is only fair. Wilcox is not as good. When you go into central Mexico, reservoir quality in the Cenozoic sands is very poor because the rivers are short and they are eroding the material that is exposed in the mountains. And that includes volcanics, carbonates, and lithics. Not much quartz. So these sands are very poor, and the area here, which was kind of a depot center, which everyone knows as Chicontepec, suffers through the poor quality of those sands. However, when you get into southern Mexico, you get better quality sands. There they are immature, arcosic sands, but still good quality. Now, these conditions, of course, you need to bear in mind as you come around and look at, for example, look at the amplitude anomalies. You need to calibrate the different kinds of sands. As you look at the porosities, the E-logs, you need to calibrate the different grade types. And as you look at the permeabilities, you need to be concerned about the diagenesis effects that these different types of sands will cause to the pores. So, in conclusion, how would I suggest you would meet this challenge? How do I think you're going to meet this challenge? Well, I think you will, next John, yeah, apply basic principles and critically review the data. Yes. Come up with creative ideas. Don't be stuck with the ideas that Pemex has had. Come up with some creative ideas of your own. And of course, lever the new technologies, new drilling technologies, new seismic 3D acquisition technologies, new EOR type of technologies. You will have to do that. And finally, and maybe you will be able to put together the elements of these petroleum systems in different ways to eventually come up with new plays for oil and gas in Mexico. And so I think to meet the challenge that I put out at the beginning of the talk, to meet the challenge, I think you will be able to, if you go through this process, you will be able to come up with perhaps some major new discoveries. And that way, discover some major new fields. So good luck to you all.
Colin. Oh, sorry. Thank you for coming up and giving us this talk. That's a little info. We've got time for questions, but I'm going to ask one since I'm the VP and I get to. Question has to do with those BRECCIAs. Oh, sorry. The question has to do with the BRECCIAs that you were talking about. Costa Rica trend. Like, how many people in this room have tried to drill a lookalike Costa Rica trend? I'm the only guy? Come on. No, look, my wife has done it too. You know, for career stability, I've decided to not do that anymore. But talk to us a little bit more about the BRECCIAs, the limestone breccia. That's a very unique play. You don't really see that as a good reservoir anywhere else in the world.
I think that's right, John. It is Mexico's type locality. It's very difficult to take from anywhere else in the world because the breccias themselves are thick, hundreds of feet thick. The folds on which they occur are big folds, so that the beam of carbonate has been broken, so they are highly fractured, and they have this triple porosity that I mentioned. And I might mention that, I might say that that in itself creates a major problem for EOR. How do you undertake an EOR program in a triple permeability rock? I don't know.
Do you think that kind of brecciated limestone or
do you think the brecciated limestone play will, I guess you implied it was going to extend into the Pico basin there? Am I right? Is that the right name of it there, the Yucatan?
Well, it's known to exist from wells in the immediate onshore and offshore shallow water. And so you're saying, do you expect it to extend along the in front of the edge of Yucatan? Yes, I'd say so.
Okay, I'm going to open up the questions from anybody else. Go ahead.
Colin, another BRECCIA question. Is any of the BRECCIA associated with the asteroid impact of the late Cretaceous?
That's what, yes. I mean, the people have, investigators, especially at the Mexican Petroleum Institute, have related the big thicknesses of BRECCIA to be caused from impact just on the northern part of Yucatan, and whatever tsunamis and that kind of thing that happened. But you also find breccias lower down in the Cretaceous. It's not just at that very top. So that's certainly considered one of the possibilities.
So no impact production in onshore Yucatan?
No.
Any other questions? Don?
Is alteration enhancing them, or is it including the breccias?
I'm not quite sure I understand.
Is hydrothermal or alteration hindering porosity in the breccias, or is it enhancing?
Yes. Well, it's a good question, because a lot of the breccias are dolomitized, in fact. And when that's the case, they are enhanced, much better matrix porosity. And of course, the dolomites tend to get more fractured. So I would say yes. The fluids that dolomitize, they're enhancing the reservoir.
Is there any mappable relation between that and the polar axis?
Not that I'm aware of.
Janet Combs?
On one of your maps, I think it was Leeds or something, I can't remember, all the red dots that were in the Orgos Basin right next to the South Texas gas plant. So I'm sure those are Pittsburgh Frio gas. Is there any market for gas in Mexico since there's none in the U.S.?
Well, yes, that's a separate talk. But yes, Mexico has a deficit in their production. Sorry, the question was, is there a market for gas in Mexico? And yes, there's a deficit of production in Mexico. The demand is increasing. The gas production, domestic gas production, is decreasing, and gas imports from Texas are increasing. And what the Mexican government is planning to invest in more, or to find investors to increase the pipeline capacity to transport more gas from the north to the south and the central part of the country.
What is your opinion about the opportunities for small companies, independents, to go on these opportunities? Is it maybe a large company?
Well, that's a very interesting question, because I've looked. No, sorry. The question was, in my opinion, is there an opportunity? Are there opportunities for small independents coming up in Mexico? And it's a very interesting question, because I think there definitely are. There definitely will be, because in the offers, the blocks that are coming up, both the joint ventures with Pemex, but also, at least for the first round, include big opportunities for majors, opportunities for independents, but also some small fields or small blocks that independents, the small independents, with very low overheads, I think could really get their teeth into and make something of it. So I would say there's something for everybody. Something for everybody. You just have to know what to choose. and what to focus.
How much of that investment that you showed on the early chart was onshore versus offshore, in your opinion?
On the original chart, when we showed the production history, cumulative production, you had that investment underneath it, and a big spike there.
Most of it would be offshore. Most of the last 10 years investment would be offshore. Not all of it, but most of it.
How hard have Pemex been trying to get a development solution for the big statics like Quantitech and the other onshore fields?
But you can't compare.
Any of the onshore static fields, how much effort have Pemex put into those over the last?
I'm not catching, I'm sorry. I need to come closer. And then I'll repeat it. Well, you can.
So how much genuine effort have Pemex put into trying to get a development solution for those difficult reservoirs around Quantitech and the other large onshore fields that they have put up for collaboration in this initial round?
Well, the main question is around Chicontepec, and how much has Pemex how much effort has Pemex put into trying to make Chicontepec work and develop it? We put a lot of effort, invested a lot of money, and until a few years ago had very little success. The production increased a little bit, but because each well didn't produce very much and declined quickly, they were kind of on the treadmill and didn't make much effort. So they put Chicontepec out for pilot projects to four service companies and one independent to try different methods. And those companies succeeded, at least to start with, in getting production of about an order of magnitude greater and declines, steep declines, yes, but leveling off at stable production about an order of magnitude greater by doing horizontal drilling and hydrofrac, and multiple fracking. But Pemex realized that they are not expert at that, and so they put out some blocks for tender last year, and the blocks have been taken up. Now, the remaining areas will be included in some future rounds. So I think Pemex has realized this is not for them. They've tried, and it's not for them. They need expertise of, first of all, where are the sweet spots? How to identify the sweet spots from 3D seismic characterization. Secondly, how to drill, and then how to manage the stimulation. And so they're putting that out. The other major fields, I'm not quite sure which ones you refer to. I'm not sure which fields you refer to. Most of the major fields onshore are mature and then decline. The end of their economic life as far as Pemex is concerned, which is why they're trying to either farm them out or get a joint venture. And it'll be up to the new partner to come up with a new technology, new ideas to bring in, and to try to make some money.
Terry? Sorry.
Does Mexico have a source of CO2 for visible flooding?
Does Mexico have a
source of CO2 for possible visible floods?
Yes. There's a field in the south that actually produces about 50% CO2 and 50% methane. And they've done some pilot tests on injecting that. And then because there's a lot of volcanics in Mexico that cut through that are in the volcanic belt, then there's a lot of potential for CO2. But I'm not an expert on exactly where that would be, but theoretically I would say yes. It's a good source of CO2.
Man in the white shirt who I don't know.
Yeah, Colin, just a question about relationships in Mexico. I mean, you've had a long, long history of building relationships in Mexico. And we all hear that Pemex and the government is really interested in transparency in this whole process. What kind of guidance would you give a large company or a small company in terms of going to Mexico and trying to meeting with people and developing the relationship? Would you go visit CNH since they'll make the decisions on partnerships? Would you go visit Pemex? Would you go visit them all? Could you give us any guidance on that?
It's a very interesting question, and it's difficult because the situation is changing, or has just changed. And Pemex now is no longer what we used to consider, the state oil company. It is, I think, just like any other major international oil company. This happens to be owned 100% by the state, but it is now your competitor. So would you go to talk to Exxon? Yes, in the bar or something. You might want to, you want to know the people from your other company. Or would ExxonMobil want to talk to Shell? Yes, but on an informal level. And you could even have joint talks, at least talks about joining a kind of joint venture or a joint strategy. But don't expect to get any sweet deal from it. When you go and talk with CNH, it has to be so transparent, and if you do, you have to talk to two representatives of CNH at the same time. And minutes have to be taken that will become public. So you can't talk about your own company's secrets. It has to be very general. Is that roughly?
Yeah, I was just wondering because CNH will make the partnership decisions. That's out of Pemex's hands.
Right.
So I'm just curious about, for you, how you approach that potential partnership arrangement.
Oh, I see. Good. Yeah, good question. Well, make an appointment with CNH to go and say what your strengths are, what you want to do. Are you a CO2 injector? Have you got experience of that? And you have to be able to show that around the world so that they put you down. Okay, this is your strength. They'll look for an opportunity for you to apply that. Or are you a deep water explorer? Where have you done? What are your strengths? You have to. You go and make an appointment with two commissioners at the same time. So if you're doing anything proactive, I would think that's the thing to do. Yeah, John?
Colin, what's your understanding of when what has been Pemex proprietary packages, both for ground zero release, maybe opportunities as well as ground one?
You're saying about when data would become available?
Yes.
I think it would become available. It won't become available until the packages, until the specific packages for round one become available. My understanding is round one might be phased, different parts. So it would be at different times, different parts and different times throughout the year, and data would become available for those data packages, which of course makes it difficult for you to know which package to focus on, which package to buy ahead of time.
Can I ask a question?
Yeah.
Are they going to start like a library? In Brazil, they have an archive database of which you can get a membership of, and you pay a membership due, and you get a certain number of credits to buy data from them, and then you can buy stuff on top of that. They don't have anything like that, anything?
Sounds like a good idea, but I haven't heard anything like that.
It's a good money-making business.
Yeah.
Any other questions?
I think that Mexico has enough qualified human resource.
Colin, what was the question?
Yeah, just do I think that Mexico has enough qualified human resource? I think they have some very good qualified people. Whether it's enough to kind of duplicate, not duplicate, but multiply for each company that wants to be involved, I think that that is a big issue at the moment. So education, both not just in the universities, but on the job education, we think is going to be very important for small and large companies going into Mexico. And we have to consider that element of on-the-job training.
Yeah, there.
Could you speak to the issue of security, particularly for small companies, individuals going into Mexico that try to do some good?
Well, yes, security is certainly an issue. And if you don't have experience in Iraq or places like that, then you will be very worried. Very close to the border would be, I would say, for a company that has no experience with security, would be a no-go area. Lewis, who has a concession, have a block there, I think they're familiar with it. Mining companies that have concessions in that area will know how to work in those areas. But for a company coming in, I think that would be very difficult. Also, areas around Tampico, Costa Rica, out in the state, in the country, could be problems for personal security as well as equipment security. You know, so equipment being stolen on the street, on the roads going out into the country, or even equipment on site being stolen. So unless you have experience with security, I would think it would be a problem. It would be a concern. And of course, it's an extra cost.
Yes, that's it. I want to thank you.